both of these algorithms have this kind of problem. One is underfit, overfit, and best fit. So our objective slide. Okay. Wait. जी बेटा शो हो रही है स्लाइड्स? जी बेटा स्लाइड्स शो हो रही हैं आपको? जी सर, जी हो रही है। ओके बेटा गौर से सुननी है सारी चीजें, ठीक है? थोड़ा सा है जरा टफ। जी बेटा, so both linear regression and logistic regression have a problem of underfit and overfit. Okay, as we discussed in previous week. Our objective is to develop a learning model which is just right or best fit. So over here, it's a linear regression. Over here, we have polynomial regression. Over here, we have quadratic equation because it's x square. So this causes overfit because it exactly passes through each and every point. It underestimates the pattern in the training example. So we call it underfit. Underfit cause high biasness. Overfit cause high variance. Biasness means we are assuming that the relationship between size and price is linear, but actually data does not represent a linear relationship. So that's why it causes biasness in the data, high biasness. For high variance, you can see for example for this house price and this house price. This house is small as compared to this one, but they have a price difference. It has a higher price as compared to the bigger house. So this is one kind of a problem we got in overfit. So we need just right, the best representation. We have to develop such a model which is best represent, which is neither underfit nor overfit, but it needs to be the best fit. Best. Now, if our algorithm same is the case, this underfit and overfit also falls in logistic regression. Logistic regression के अंदर भी which is used to solve the classification problem. Logistic regression which is used to solve classification problem. Only difference is that we have this model and we have g of z, and g of z is a sigmoid function. Sigmoid function. Over here you can see this is we draw a straight line, but this straight line does not clearly develop a decision boundary. Decision boundary. Because there are many examples which are misclassified. So this is what we call it as underfit, and it again cause high biasness in logistic regression. If we look at this one, this is the exact model, exact fit of the decision boundary. Very complex. That's why there are many terms. It's a polynomial logistic regression. So it's exact fit. Exact fit. Okay. So again, the problem is overfitting, and it causes high variance. And over here, it's underfit and cause high biasness. What we need a just best fit. So this is the just best fit curve for this particular training examples. Just right or best fit. Okay. Okay, so this we already discussed in the last lecture, the problem of underfit. So when we develop a model, it might possible that our model is underfit or overfit. We have to address these two problems in linear regression, and same problem also exists in लॉजिस्टिक रिग्रेशन. जो भी मॉडल आप ड्रॉ करेंगे उसमें ये प्रॉब्लम आ सकता है. अब हाउ टू एड्रेस ओवरफिटिंग. ठीक है, ओवरफिटिंग को अगर प्रॉब्लम मॉडल के अंदर इफ देयर इज अ प्रॉब्लम ऑफ ओवरफिटिंग इन द मॉडल, हाउ टू एड्रेस इट. सो the most easiest way, you can we cannot say that it's an easiest way, but it depends on your use case. Collect more training examples to address the issue of overfitting. Okay? Just increase the number of the training examples, and it's the most easiest one and the most difficult one. You can say that because there are some situation in which it's very difficult to increase the number of training examples. In some, for example, just we have the example of tumor size. So if we have patients and they have the tumor and we know their symptoms, then it's possible. So sometimes, for example, in the case of example of the tumor, it's very difficult to increase your training data set. It's very difficult and very expensive. So, but this is one of the solution. If there's a possibility that you can increase the number of the training examples, over here we have few training examples. But over here we have many training examples. So you can see, because larger number of the training examples, this curve, which is overfit, will transform into best fit. So this is one of the solution, just to increase one of the direct solution is to increase the number of the training examples. But in some cases, it's very difficult to increase the number of training examples because your training examples are real-time data. For example, in the case of tumor size, or in the case of house prices. For example, if there are very few houses in the locality, or if there are very few houses in the locality which are being sold in last few years. So this is the case. We do not have much training examples, but this is one of the way to address the issue of overfitting. Collect more training examples if possible. If you have a chance, if you have a possibility and your model is overfit, one of the easiest or the direct way is to increase the number of the training examples to address the issue of overfitting. So this is the one remedy. Number 2, feature selection. Include or exclude features. In order to reduce the overfitting, just do not use many of the polynomial features. Just x1, x2, x raised to power 2, x raised to power 3, avoid using polynomial features, or one way, avoid using just not to use so many of these polynomial features. Just for example, if we have one feature x, so we develop model like x square plus x3 plus x4. So this is polynomial. So these polynomials will cause the model to overfit. So one way is to reduce the polynomial features, and second way, you can include or exclude important features. But it's little bit tricky, because when you reduce, for example, over here we have x1, x2, x3, x4, x5, and so on, xn. This is why. So maybe we consider x1 is important, x2, x3, x3 is not important, x4 is important, x5 we exclude, we make these features zero. We exclude them while developing of our model. So this is also another way. So first one, increase the number of training examples. Number two, include or exclude features, feature selection. Number three, avoid polynomial features. Polynomial feature. So these are three methods. But the problem with the feature selection is that if we all select features to include or exclude all features plus insufficient training examples, the model will overfit. You have, for example, x1 to x5 or x100 features, but you have insufficient number of training examples. Number of training examples. Then your model will overfit. What is the solution? Use selected features. For example, over here we just use we think, but there are some algorithms just like PCA, principal component analysis, which do feature selection automatically for us. But this is not the part of your course at this time. But there are some algorithms which are designed specially for feature selection. Because, for example, if we have 100 features, we include all of them and we have very less training examples, the model will overfit. We use few features, but we use polynomial features, then again the model will become overfit. So selected features, just right feature selection, it will help to reduce the problem of overfitting. But there is one disadvantage of using feature selection. Because we do not know, there is a chance that a useful feature might be dropped. ठीक है, हम कोई एक feature, for example, average income or number of flow, we do not consider, we make number of flows equal to 0. So, but in many cases, number of flow is an important feature. If we exclude this feature, there is a disadvantage that there is a disadvantage that some useful information is lost. Our model may become underfit. So excluding or including features is a little bit tricky. You have to work with different. You have to work with different features to see which features are important and which features we can ignore. Later on, maybe if you go on in this field, you will find some algorithm which will help you in feature selection. So in order to address the problem, and next, this is number 4th method is used regularization. What is regularization? Reduce the size of the parameters. Values reduce. We do not include or we do not exclude features. In regularization, we do not exclude features. हम features exclude नहीं करते, but we reduce the values of the parameters. For example, if we have two parameters, w1 x1 plus w2 x2, goal is to reduce their values. And to reduce the values of the parameters, not the features, parameters. We include all features, for example, x1 to xn, all features, but objective is what is regularization? We reduce the value of w1 to wn. For example, previously these are our different features, and it has the value of 28, 385, 39, 170, 400. These are very large values for the parameters. So instead of eliminating the features, we are reducing the value of the parameters to penalize the effect of that feature, to reduce the effect of that feature. So instead of using very large value of the parameters, the goal of the regularization is to reduce the value of the parameters. So previously, for example, reduce the size of the parameters. Previously, we have 28, 385, 39, 174, and this is B. Very large values for WJ. But over here, we are using very small values of WJ, and we very small values of WJ. So you can see from overfit, our model is transformed to best fit. Best fit. Remember, you can also change the value of, you can also reduce the value of B, but B does not have any major effect. So you can include, but normally we exclude the transformation of B. And B, we do not change B. We do not change B. So what is the summary? How to address the issue of overfitting? Collect more data. You can select you can select feature selection. For example, if we have x1 to xn, maybe we just take just 50 features, x1 to only 50 features, like this. Number 3, there is one or another, I told you that avoid polynomial expressions. This is also one. And the fourth one is reduce the size of the parameters, particularly WJ. We do not ओके एनी क्वेश्चन बेटा यहाँ तक ठीक है जी ये है कुछ मेथड these are the methods with which we can address the issue of overfitting both in No. Okay, beta. So, any question? So these are the methods. Okay, I just muted. So we started from here in the previous lecture. Same problem: underfit, overfit, and best fit. Same, this problem also lies in classification problem, underfit. This is best fit, just right. And the last one is overfit. In order to address these issues, we have four methods. Collect more data, but this is sometimes challenging to increase the size of your data. Feature selection, sometimes it's also challenging because we do not know which feature is important and which feature is might not be important. So for it might happen that we exclude a very important feature from our model. So it's also not very it's also a challenging way to address the issue of overfitting, because if we reduce the number of features, there's a chance that information might be lost. Third one, avoid polynomial regression. This is also one way, but it also does not work sometimes very well. The most important way to address the issue of overfitting before the address of overfitting is to use regularization. In regularization, we do not exclude features. हम features exclude नहीं करते, बल्कि उन features के साथ जो parameters हैं, W1 to W0, W1 to Wn, in parameters we reduce the values of these parameters. Next we will see how we can reduce these parameters with the help of regularization. Okay. So hopefully now we have to look at this one. Reduce the size of the parameters, just like here. Previously, these parameters have very high values. Very high. So they cause overfitting. Same model over here. Instead of eliminating the features, we are not eliminating the features. We are using small values for Wj. Now the values of the Wj are very small. Since the Wj is small, so the effect of this feature also, their contribution of this feature also become small. We can also change the value of b, but it does not make any major difference in case of overfitting. So better not to it has limited uh, well reduce values of the parameters, and our parameters is w1 to wj. These reduce the j is from 1 to n. 1 to n. So this is the way to regularization. So hopefully you got this point. So these are the few methods to address the issue, but every method have its advantages and disadvantages. Most commonly used method is regularization. It's the safest way because more data collections, feature selections, they have really some disadvantages which can which can make the model underfit. We are addressing the issue of overfitting, but because of less number of data or feature selection, there is a chance that our model might become underfit. So what is regularization? So in order to do the regularization, we have to rewrite the cost function and gradient descent. Okay. Now we have to include one term. We call it as regularization term. Regularization to reduce overfitting. we will going to rewrite the cost function with regularization. Cost function भी दोबारा write होगा, right? दोबारा इस सेंस में होगा कि उसमें एक कंपोनेंट regularization का ऐड होगा, बाकी cost function सेम रहेगा. Same is the case with gradient descent. ठीक है जी बेटा, यहाँ तक कोई क्वेश्चन? क्योंकि आगे थोड़ा सा मैथमेटिकल है, तो अगर ये बेसिक समझ आ गई तो होपफुली आगे भी समझ आ जाएगा. ओके आगे कुछ मैथमेटिक्स है, घबराना नहीं है इससे, कोई खास टर्म नहीं है, बस सेम प्रीवियस है जो हम लीनियर रिग्रेशन, व्हाट वी डिड इन लीनियर रिग्रेशन, व्हाट वी डिड इन लॉजिस्टिक रिग्रेशन सेम है. जस्ट वी विल गोइंग टू ऐड वन मोर component into these two equations of cost function and gradient descent. सिर्फ ये है और कुछ नहीं है. So what we are want to do, we have this model W1 W2 X2 plus B, and this model, if we use these two, we use polynomial regression. We have included X3, and this is our you can say that the underfit best fit model. But if we include these terms, it become overfit. Overfit हो गया. Now how to make best fit? ठीक है. फॉर एग्जाम्पल ये आपका एक, दिस इज योर अंडरफिट मॉडल. Underfit model, we include extra terms to make it, we included extra terms, but these extra terms make the model, sorry, say how we can going to make it changes to best fit. Our cost head and square. So go W3, W4, and with very big number of multiply these features with very big number. What these features will do, it will, because overall goal is to minimize the cost function JWB. So because these values are very big, so this cost function will try to reduce the values of W3 and W4. W3 and W4. Because if the value of W3 is small, then this overall function will be small. But if the values of W3 and W4 are big, then the cost function means the difference between actual and the predicted becomes very large. So we have to, as objective is to reduce the values of the parameters as small as possible, as small as possible. So if you want to minimize this function, the only way to make this new cost function small, if W3 and W4 are both small. ये small होंगे तो हमारा if our cost function will become minimized. When it becomes small, overall their effect be very less, very minimum. When they are like this, so their effect will be very minimum. So the goal is to reduce the values of W3, W4 as small as possible. So for example, this is our cost function, what we have studied in linear regression. Linear regression, house prices example. These are our features from x1 to x100. This is our target variable y. So you have to reduce the values of the parameters. So in order to, for example, these are our parameters, W1 to W100. For example, if features are up to 100, and B, total number of features are n. So W1 to Wn, n is equal to 100. So, and these are our features, W1 to W100 and B. We do not change the value of B. Our objective is to reduce the value of these parameters. In order to reduce the values of these parameters, we will add this term to our cost function. Same cost function, no change at all up to here. We added term plus lambda over 2m sigma j is equal to 1 to n wj of square. This lambda is known as regularization parameter. This lambda is known as regularization parameter, and value of the lambda is always greater than 0. So we added one term. This is, we call it regularization term, lambda divided by 2m j is equal to 1 to n wj square. We call it as a regularization term. We can also add a regularization term for B, same like this one, because over W is from 1 to 100, so we have to use sigma 1 to n is equal to 100 in this particular example. We can also add a regularization term for B in the cost function. 1 lambda by 2m b square, b square, like w j square b square, because b is only one value. But normally we do not do this. We can exclude this term. So only the important regularization term we will use only for the wj. We add this term we develop a new cost function by adding regularization term. So what is regularization term? Just lambda by 2m sigma I is equal to 1 to n wj square. We add this term. This is what we call it as regularization term for the parameters w. We can also add this regularization term for b, but b does not have much effect, so better to exclude it. Can include or can exclude, like it's, in order to make it simple, it's better to exclude it. कि आप इसको जो है वो क्या कर दें, exclude कर दें. So now our new cost function with regularization in the case of linear regression, because in the case of linear regression, our cost function is mean squared error. Squared error, like this, same, no difference at all. We added this term lambda by 2m, j is equal to 1 to n wj square. Okay. So what this cost function will do, this cost function will keep the wj small. As a result of which our overfit model will change into best fit. For example, if lambda is 0, if we take the value of lambda is 0, lambda is equal to 0, this term becomes 0 and our model is overfit. Okay, it becomes overfit. But if we choose, we want to see the effect of lambda. If we choose lambda a very big value, we choose very big value for lambda. Okay. So what will happen if we have lambda is very big? Then all of our these terms becomes nearly equal to 0, because lambda is very huge term, and we left with only b, and this b will be a horizontal line. If lambda is 0, we have overfit model. Lambda is 0. If lambda is a very big number, then our cost function becomes huge, and we left with only b. If we plot this b, now these are our data points. These are our data points, but we left only with b, so our model will look like this. It becomes underfit. Very lambda is 0, it becomes overfit. If the value of lambda is very high, it becomes underfit. So we have to choose some approach. Mute kar le. Now we want to see the effect of lambda. If lambda is 0, this whole term becomes 0 and our model becomes overfit. Okay. If lambda is very huge term, then all of these will become 0, and we left with b. If we plot b, we get this horizontal line. So this is our data points are these. So this is underfit. So you can see that the value of lambda helps to transform the model from underfit to overfit. So we have to choose some appropriate value of lambda. Just we choose an appropriate value for alpha, previously the learning rate. Same is the case with lambda. We choose some appropriate value that can make our parameters as small as possible. Now you can see that because of this term and appropriate value of lambda, our model becomes best fit. Best fit. So regularized linear regression will look like this. This is our cost function, same as previous, but we have this new term. Okay, and gradient descent is like this, no change at all in the gradient descent. But this is our gradient descent. Again over here we have xj, और यहाँ पे हमारे पास क्या है 1 है xj. But when we took the partial derivative, there will, because of this term, we have another term over here, lambda by m, because w square, when we took the partial derivative, it becomes 2w lambda divided by 2m. This 2 is gone. This 2 left with lambda wjm. And since we already said that we do not have to regularize b, so there is no change in b, only change in w of wj. Now this is our gradient descent equation with regularization. As we add this component lambda by m w of j. Same is the cost function for linear regression, no difference at all. Just we have included this term. This term will keep our parameters as small as. Again, in order to implement the gradient descent, you have to simultaneously update. So this is only term, a new term is this one. We took the alpha outside. We have lambda by, this is our regularization term in gradient descent. No change, only change in W, no change in B. B is same as previous, what we did in regularization, in linear regression. So if we multiply this alpha inside, B alpha inside, so this it becomes minus alpha, this term will come over here, minus alpha by mw of j minus alpha and minus alpha by m, or yes, this term as it is over here. So if we took wj outside, it becomes 1 minus alpha by lambda by m. So this is we can transform this equation into, this is our old linear regression update, but now we have another component 1 minus alpha lambda by m. So what this term is doing, this term is actually shrinking wj, because over there wj minus this term previously when we make update, but now this wj is multiplied by this term. We subtract this term, no, so the wj becomes also small by this term. Previously we are using wj as it is when we do not have this component. So we do like this, wj minus alpha if we do not have this term, if we do not have this term, so wj. But over here, beside this is our usual update as we did in linear regression, but now instead of using wj, we are using 1 minus alpha lambda by m, and it will reduce the value of wj. Previously we are using as it is. जी बेटा क्लियर है ये चीज कि किस तरीके से हाउ दिस लैम्डा टर्म या regularization term is forced to reduce the value of wj. Previously our wj is this one. Okay, if we exclude this term, so you see wj minus alpha partial derivative of cost function. So over here we have wj. We are subtracting this update directly from the wj. But now instead of wj, when we include this regularization term, this wj, instead of using this wj, we are using wj 1 minus alpha lambda by m. So this term further reduces the value of wj. So that's why it shrinks our parameters. Close to parameter, it shrinks our parameters. You see 1 minus, for example, if we took the value of lambda is 1 or 10, something like that, for 50-20 example, now instead of using 1, we will use 0.998. Over here we are using 1, but over here we are using, we are multiplying wj 0.998, so it has some smaller w. बेटा क्या any question यहाँ तक? But simultaneously update वही है what we did it in linear regression and logistic regression, so no need to discuss that one. Derivative, it's very simple. I will repeat that thing. So this is our term. If we take the derivative of this term, so what will be the derivative? Lambda 2m, derivative of wj square sigma will be 2wj, so it becomes 2wj. 2 will go out with 2, we're left with wj but by m. So this is the derivative. Later on, so where we put this term into the this one. Alpha is learning rate just like previously. In previous, we have new term is lambda. Lambda is a regularization coefficient, and its value sometimes we take one between 1 to 10. Alpha is the learning rate what we have did it previously in linear regression and logistic regression. Jibit is clear. We have only this new term. In cost function, our term is this one. We added this term in the cost function. And because of this term, our gradient descent become this. No only change in Wj. Only change in the Wj. There is no change in the V. Because of this term, we can simplify it in the form of this one Wj1 minus alpha. Now you can see instead previously we are using Wj minus alpha and partial derivative. Now instead of using Wj, we are reducing its value by 1 minus alpha lambda by n multiplied by Wj. This is our older update, no change at all. So this is how the cost function and gradient descent will be modified by introducing regularization. इसमें एक कंपोनेंट इक्वेशन के अंदर एक रेगुलराइजेशन का कंपोनेंट जब वो ऐड होगा उससे क्या चेंज आती है दिस इज व्हाट वी डिस्कस टुडे अगेन सेम प्रॉब्लम exist in logistic regression. Logistic regression में same problem exist. So there will be for example, I will repeat the same thing with logistic regression. This is an overfit model, and for this one we have our function is a sigmoid function 1 plus e minus z, and our cost function is look like this. Now we will add this term lambda by 2m sigma j square from j1 to n. So this is a new cost function. We added this term in the logistic regression cost function. Gradient descent is same, but this value is different. So when we add this term, so again lambda by mw of j, no change, no need to change b, only need to change this. So this is already the previous one, and we add this component regularization term again. So this is what we do in order to address the issue of overfitting. जी बेटा, any question यहाँ तक? What is underfitting? What is overfitting? What is best? How to transform our overfit model to a best fit by adding regularization component. There are 2-3 other ways to address the same issue by increasing the number of the training examples or by feature selection. These are also ways. Sometimes they work, sometimes they do not work, but regularization always work. जी बेटा, any question यहाँ तक? Okay, this is what we call it as supervised learning. This is supervised learning. There is another type of supervised learning. We call it as deep learning. There are totally only the definition is included in this course. So supervised learning, but using deep learning. So again, since it's a supervised learning, you have the training examples, training data. कि आपके पास क्या मौजूद है? Training data मौजूद है. But in deep learning, instead of using, we use how our brain works. So normally in brains, the thinking process in brain use neurons, and neurons, each neuron is connected to another neuron. Just like this is one neuron, it has cell body, nucleus, we call it as axon, dendrites. You have might be studied in your biology. And this neuron, it get inputs from other neurons, process it, produce another output, and forward it to another neuron. It's also get input from other neurons, process it, and forward to the other. And these inputs are in the form of electric signal. Electric signal. This is how a biological neuron. We have input, we have some processing, and we produce output based on the input. This is how our brain works. Same concept in 80s is transformed to develop algorithms. We call it as deep learning by using artificial neuron network, ANN. It's developed around 80s, in mid 80s. Artificial neural network. This is biological neuron. How our brain works. Our brain works. Same thinking process is translated in the form of artificial neural networks. So in artificial neural networks, we have input, we have neurons, and we have output. So if I show you some example, okay. So these are your inputs, and these are neurons, and these neurons might be there are this is one input layer, one output layer, and might be there are thousands of or millions of hidden layers. So these are all connect. So input come from here. These are the different inputs or the feature vector, our features. Every feature is multiplied with some weight and is connected to all other, it will produce input to all the neurons. These neurons will again produce output, and there is a weight, and it will give it input to all other neurons. So that's why these are very complex and computational extensive networks until we get this predicted output y. Again, we calculate the output. We have input, we have output from the training examples, and we find the error. Based on these errors, we back propagate in order to adjust these weights so that our error between input and the target y becomes minimum. So when the error becomes minimum, we can say that our model is trained. Now when we input our unknown examples, it will give us the right output. So this is how our neural networks work. It's totally different from it's a supervised learning. ये भी एक supervised learning है, but its architecture is totally different from machine learning. जो अभी linear regression and the logistic regression, they are more inclined towards statistics. But this is a mimic of how our brain works. You see in this example. So for example, customer age, customer debt ratio, monthly income, X1, X2, X3, we start with some random weights. There are some hidden layers of neurons. They will produce, again, they process this information and produce output, and over there we have weights. So we have to adjust these weights in such a way that our input and our output match the training examples. errors. In other words, we have to reduce the error. So when these weights are adjusted between input layer and hundreds of hidden layers and output layers, now when we feed a an unseen example, it will give us the right output. So this is a totally different thing. It's a branch of machine learning. We cannot say that it's not the branch of machine learning. It's a branch of machine learning, but its working is totally different. इसका way, इसका जो architecture है, it's totally different. Input, hidden layers. Every layer is connected to all other new ones. So that's why their computation, they are very computation extensive networks. So this is another way to solve machine learning problem, and there's a full course over it. बेटा any question यहाँ तक? Hidden layer एक भी हो सकती है, and thousands and millions of hidden layers possible. Just like we do it in large language models like ChatGPT and like this. You can see over here. So you need to understand the difference between machine learning and deep learning. They are branches of supervised learning, but their working principle is totally different. Two different way to solve a similar problem. So only definition and the difference is part of your course. Now there are one or two definitions more before we end this course. So unsupervised learning. So unsupervised learning, we do not have the labeled data. We have data, but we do not have the labeled data. So the most common example of unsupervised learning is clustering. You just clusters the things. After clustering, you label them depending upon your output. So you do the clustering just like we have data, we run some kind of a clustering algorithm. It will group different examples together depending upon the features. Now we can say that this example is, for example, a classification problem. You can group, maybe these are the number of students coming from different districts. These are 3 different districts of Punjab, depending upon the feature. So now after looking the output, you can after looking at the output, you can label them. So this cluster shows this cluster shows this. So this is what we call it as supervised learning. Unsupervised learning, we do not have labeled data. We have just training data that is not labeled. In classification, we have labeled data. We group them, but we have training example, we have labeled data. But in clustering, we also group them, but we do not have any. We have data, but it's not labeled. So when the data is not labeled, and labeling data is also a very extensive job. It takes a lot of resources. For example, you have millions of examples, how to label them. So instead of doing supervised machine learning, we can just do the unsupervised learning because it's very difficult to do the labeling of the data. It's huge, it's expensive, it's time consuming. So one quick way to do this thing is to do the clustering algorithm, to run unsupervised machine learning. And you can do cluster. Sometimes we call it clustering. In some domains, we also use a term anomaly detection. So anomaly detection and clustering are two most commonly used or famous examples of unsupervised learning. And beside that, we have recommendation systems. Because these are full courses, recommendation systems. So in recommendation systems, it's also a kind of unsupervised learning. All our Amazon, Facebook, Netflix, they recommends ad to you. So this is also a kind, is some kind. They have your profile, they have the ads. So based on your profile, they recommend you some kind of ads which have the highest probability that the user will going to click. And recommender system, this is unsupervised learning. Recommender system sometimes use sometimes use supervised or semi-supervised learning. So reinforcement learning is also a kind of learning normally we use in robotics. It's also normally uh, it learns with experience. So broadly, we have two major classes of machine learning: supervised, unsupervised. In supervised, we have classification, we have prediction problem, and in order to solve supervised learning problems, we can also use deep learning. Deep learning we use कर सकते हैं. So these two slides are new, but just for the sake of definitions only, just this. तो बेटा मैं वीक में होपफुली अवेलेबल हूँगा. तो अगर if you have any questions, कोर्स आपके कोर्स मटेरियल आपका यही है. So if you have any question, you can come and discuss, no problem at all. And your mid and final now, your final exam. So your final exam will be 24 marks plus 20 marks practical. So 24 marks theory, 20 marks practical, but there is not major difference between theory and practical. Short questions. There will be short questions, multiple, just like mid, short questions, definitions, differentiations, and no multiple questions like this. Only short questions, definition, differentiations, or mathematical short questions पूछे जा सकते हैं. And from the Jupyter notebooks, only main functions, what they do only. उसमें कोई डिटेल नहीं आएगी, कोई there will be no detail, there will be no full program or a method, just most commonly used definition of most commonly used methods of NumPy and Python. सिर्फ आपको उसकी बेसिक डेफिनेशन भी याद करने की जरूरत नहीं है. यू जस्ट नो द बेसिक कंसेप्ट ऑफ दैट मेथड. फॉर एग्जांपल np dot what does it do? It took the dot product लेता है. ठीक है. कंटेंट्स की जो स्लाइड्स हैं आई विल शेयर कि मिड का कौन सा पोर्शन होगा, कौन सा पोर्शन नहीं होगा. मिड में जो स्टार्टिंग जो हमारी लेक्चर स्लाइड्स हैं, ये ओनली लीनियर रिग्रेशन प्लस लॉजिस्टिक रिग्रेशन. ये दो लेक्चर्स हैं. इंक्लूडेड रेगुलराइजेशन एंड ओवरफिटिंग. So this is the part of your mid exam, final exam. जी बेटा.
सर प्रैक्टिकल में नोटबुक से आएगा कि ओवरऑल?
Overall be in practical you can get and there might be some question from the theory plus there will be some questions from the notebook, and from the notebook the question will only be the definition of some method used in the notebook. There will be no full program or there will be no full program over there. Only the definitions of the method used in the NumPy के Python के इनके methods आपको आने चाहिए. बट भाई मैंने नोट्स आपके साथ शेयर कर दी. जस्ट ये दो स्लाइड्स नहीं है आज आपको लास्ट कराएंगे. इसमें आपको डीप लर्निंग की डेफिनेशन और ये जो 3-4 डेफिनेशन आपको आनी चाहिए. सुपरवाइज्ड लर्निंग, डिटेक्शन, रिकमेंडर सिस्टम, रीइंफोर्समेंट लर्निंग, ओनली डेफिनेशन. बेटा मर्जी से होती. जैसे जो कंटेंट्स होते हैं वो मर्जी जो डेफिनेशन है वो तो रोज चेंज थोड़ी होती है, मर्जी कर सकते बट क्वेश्चन आप उसके ऊपर प्रेडिक्शन कर रहे हो कि ये जवाब हो सकता है, ये जवाब नहीं हो सकता। स्लाइड्स कौन सी करनी, लेट मी सी, आई विल शो। सो तो हमारे पास जो लेक्चर है लेक्चर 3, लेक्चर 4, लेक्चर 5, बस लेक्चर ये 3, 4, 5 बस ये 3 है। लेक्चर 3, लेक्चर 4, लेक्चर 5। लेक्चर 5 में 2 स्लाइड्स एक्स्ट्रा हैं, 2 स्लाइड्स एक्स्ट्रा हैं एंड वो शायद मैंने भी शेयर नहीं किया, आई विल शेयर विद यू, वो मैं आपके साथ शेयर कर दूं। पेपर पैटर्न just short questions, definition or some different, there will be no long question, लेकिन short questions होंगे बस। और प्रैक्टिकल के पार्ट में शॉर्ट क्वेश्चंस डेफिनेशन आ सकती हैं एज इट इज फ्रॉम द थ्योरी पार्ट, प्लस मेन डेफिनेशन और कंसेप्ट ऑफ numpy और पाइथन फंक्शंस यूज्ड इन द जुपिटर नोटबुक्स। बेटा डेट डिपार्टमेंट से पूछिएगा, आई हैव नो आइडिया।
सर जो स्लाइड्स इंक्लूडेड हैं शेयर कर देंगे ग्रुप पे।
आपने शेयर किए हुए सिर्फ 2 लास्ट स्लाइड्स में मैंने शेयर किए, बाकी कुछ शेयर लैब शेयर कर दूंगा, लैब शायद शेयर नहीं। लैब्स भी जस्ट आपने लैब्स भी ये जो लेक्चर 5 है ये लैब्स आप स्किप कर दें, सिर्फ हमारे पास लेक्चर 3, 4, लेक्चर 3 और 4 की आप कर लीजिएगा। इसमें से इसमें से जो हमने ड्रॉप की हैं वो रेगुलराइजेशन वाले जुपिटर नोटबुक्स यू कैन स्किप देम, सिर्फ जुपिटर नोटबुक, बाकी मैं क्लास में करवाएं। It is question same like mid exam। प्रैक्टिकल में शॉर्ट क्वेश्चंस इंक्लूड होंगे, डेफिनेशंस भी इंक्लूड होंगे, डिफरेंशिएशन भी आ सकती है। डेट का बेटा मुझे आइडिया नहीं है। लेक्चर 3, 4, 5 में से यू स्किप द जुपिटर नोटबुक्स ऑफ रेगुलराइजेशन, skip the Jupyter notebooks of regularization। Slides 3, 4, 5 only, 3 स्लाइड में सिर्फ पाइथन जो बिफोर मिड हमने 10 स्लाइड्स की थी, दे आर नॉट इंक्लूडेड, ओनली जुपिटर नोटबुक्स ऑफ लेक्चर 3, 4, 5। जुपिटर नोटबुक्स ऑफ 3, 4, 5 from the 5th lecture, from the 5th slide, so you can skip the Jupyter notebooks of regularization। अपने regularization के अलावा 3, 4, 5 की तमाम Jupyter notebooks शुरू के जो हमारे 10 chapters थे Python के वो exclude हैं, they are not included in the mid। ओके बेटा, गुड लक। फिर भी अगर कोई क्वेश्चन है, कोई प्रॉब्लम है, प्रॉब्लम होपफुली आई विल बी देयर इन लैब, आई एम नॉट श्योर, लेकिन मैं होपफुली होगा, नहीं तो मेरे कोई स्टूडेंट क्लास में। ओके बेटा, अल्लाह हाफिज, थैंक यू। मैं फिर भी शेयर कर दूंगा सारा कंटेंट्स दोबारा से एक दफा।